What if I told you that a Brooklyn mechanic with an $80 trick outperformed Oldsmobile's entire engineering department and created a racing dynasty that would dominate American motorsports for decades? This isn't just another hot rod story. This is about how one man's discovery in a grimy speed shop changed the entire trajectory of American performance engineering and built an empire worth billions today. Picture this. It's 1952, and you're watching the early NASCAR races. Oldsmobile Rocket 88s are everywhere, but something strange is happening. Certain cars with identical engines are pulling away from the pack, hitting speeds that shouldn't be possible. Factory engineers are baffled. Competitors are crying foul. And at the center of it all is a mechanic from Brooklyn who discovered something Oldsmobile's best engineers completely missed. This is the story of Vic Edelbrock Sr., the Oldsmobile Rocket V8, and the secret valve job that revolutionized American hot rodding. It's a tale of how conservative engineering created an opportunity, how one man's curiosity exposed a fundamental flaw in Detroit's thinking, and how an $80 modification became the foundation of America's largest aftermarket performance empire. To understand why Edelbrock's discovery was so significant, we need to travel back to 1949 when Oldsmobile introduced the Rocket V8. This wasn't just another engine. It was the first modern overhead valve V8 designed for mass production, featuring 303 cubic inches of displacement, hydraulic lifters, and a compression ratio of 7.25:1. In stock form, it produced 135 horsepower at 3,600 RPM and 263 pound-feet of torque at 1,800 RPM. These numbers might not impress today, but in 1949, this was revolutionary. The Rocket 88, combining this new V8 with Oldsmobile's smaller 76 body, created the first muscle car. It dominated NASCAR's inaugural season in 1949, winning 8 of 9 races. By 1951, the Rocket had evolved to produce 160 horsepower with higher compression and improved carburation. Everyone knew it was fast. But Vic Edelbrock knew it could be faster. Here's where it gets interesting. Oldsmobile engineers had designed the Rocket with specific priorities. They wanted smooth, idle quality, good low-end torque for everyday driving, and reliable operation on regular gasoline. To achieve this, they fitted the cylinder heads with relatively small valves, 1.72 inches for the intake and 1.5 inches for the exhaust. The ports were sized to create high velocity at low RPMs, perfect for street driving, but restrictive at higher engine speeds. The engineers weren't wrong in their approach. The small valves created excellent turbulence at low speeds, improving fuel atomization and combustion efficiency. The restricted ports maintained high gas velocity even at part throttle, ensuring crisp throttle response. For a luxury division engine meant to power Oldsmobile's premium sedans, this was perfect engineering, but it left massive untapped potential on the table. Enter Vic Edelbrock Sr., a mechanical genius who ran a small speed shop at 1200 North Highland Avenue in Hollywood. Actually, let me correct that. He started in Brooklyn but moved his operation to California in 1938. By 1952, Edelbrock was already known in hot rodding circles for his intake manifolds and cylinder headwork on flathead Fords. But the Rocket V8 presented a different challenge entirely. Edelbrock noticed something curious when he first disassembled a rocket head. The combustion chambers were generously sized and the port layout had excellent potential. But those valves were tiny relative to the available space. He grabbed his measuring tools and started calculating. The stock 1.72-inch intake valve had a curtain area, that's the cylindrical area between the valve and seat when open, of just 1.35 square inches at maximum lift. But the ports could easily flow enough air for a much larger valve. So Edelbrock did what any good hot rodder would do. He started experimenting. Using a valve seat cutting machine and careful hand porting, he machined the heads to accept 1.94-inch intake valves, nearly a quarter inch larger in diameter. This increased the curtain area to 1.52 square inches, a 12% improvement. But the real gains came from the improved port flow. The larger valve reduced the restriction at the most critical point, where the air had to make a 90-degree turn around the valve and into the cylinder. The process wasn't simple. Edelbrock had to carefully machine new valve seats without breaking through into the water jackets. He had to reshape the ports to match the larger valves, maintaining the proper angles to preserve swirl and tumble. He had to ensure the valves wouldn't hit the pistons at full lift, and he had to do all this while maintaining the structural integrity of the cast iron heads. The first engine Edelbrock modified with his big valve heads was a revelation. On the dyno, it produced 195 horsepower, a gain of 60 horsepower over the stock 135-horse engine. That's a 44% power increase from an $80 valve job. To put this in perspective, most speed shops were charging $500 or more for complete engine rebuilds that might yield 30 or 40 extra horsepower. Edelbrock was delivering nearly double the gains for a fraction of the cost. But here's the kicker. The power gains weren't just at peak RPM. The big valve heads transformed the entire power band. Where the stock engine would start wheezing above 4,000 RPM, Edelbrock's modified heads kept pulling hard to 5,500 RPM. The torque curve extended higher, and the engine's breathing capacity increased by nearly 30% at high RPM. Word spread quickly through the racing community. The first Edelbrock-headed rockets appeared at Southern California Dry Lakes meets, where they immediately reset records. At El Mirage Dry Lake, an Edelbrock-equipped Rocket 88 hit 132 miles per hour in the flying mile, nearly 20 mph faster than stock rockets could manage. The advantage was undeniable. NASCAR teams took notice. Hudson was dominating with their big six-cylinder engines, but the Edelbrock rockets offered a new path to victory. Lee Petty, patriarch of the Petty racing dynasty, was one of the first to adopt Edelbrock's modifications. His Oldsmobile won 6 races in 1952 and 8 in 1953, all with Edelbrock modified heads. The technical reasons for the improvement were fascinating. Airflow through an engine follows specific laws of physics. At low valve lifts, the flow is limited by the curtain area, that cylindrical opening between the valve and seat. But at higher lifts, the valve itself becomes the restriction. The stock small valves reached their flow limit quickly, creating a bottleneck that no amount of porting could fix. The larger valves moved this restriction point much higher in the lift range, allowing the ports to flow their full potential. Edelbrock discovered something else crucial. The rocket's combustion chamber shape was nearly ideal for the larger valves. The stock chambers had generous quench areas, the flat portions of the chamber that come close to the piston at top dead center. These areas created turbulence that improved combustion, and the larger valves didn't compromise this design. In fact, the improved breathing allowed for even better cylinder filling, which enhanced the quench effect. The modification also revealed a fundamental conservatism in Detroit's engineering approach. Oldsmobile's engineers had certainly tested different valve sizes during development, but they prioritized durability, emissions, and drivability over maximum power. They designed for the 99% of customers who would never rev past 4,000 RPM, not the 1% who wanted to race. Internal documents from Oldsmobile, declassified years later, showed that engineers were aware of the potential for larger valves, but they worried about valve float at high RPM, increased wear on valve guides, and potential warranty claims. The small valves were a deliberate choice to ensure reliability across millions of engines. What they didn't anticipate was how easily these concerns could be addressed in the aftermarket. Edelbrock's success caught Oldsmobile's attention, but not in the way you might expect. Rather than incorporate his improvements, they initially tried to discourage modification. Dealers were instructed to void warranties on modified engines. Factory documentation warned against unauthorized alterations. But the racing results spoke louder than corporate policy. By 1953, Edelbrock had refined his process to a science. He offered 3 stages of modification. Stage 1 was the basic valve job with 1.94-inch intakes and 1.625-inch exhausts, good for 40 to 50 horsepower. Stage 2 added port matching and bowl blending, worth another 15 horsepower. Stage 3 included extensive porting, larger exhaust valves, and combustion chamber modifications, pushing output past 200 horsepower. The pricing was revolutionary for the era. Stage 1 cost $80. Stage 2 ran $150. Stage 3 peaked at $250. Compare this to a Offenhauser racing engine that cost $2,500 or a GMC supercharger setup at $800, and you understand why Edelbrock's shop was overwhelmed with work. But Edelbrock wasn't content with just valve jobs. He recognized that the improved heads needed better intake manifolds to realize their full potential. The stock single 2-barrel carburetor and intake manifold became the next bottleneck. So Edelbrock developed the first aftermarket aluminum intake manifold for the Rocket V8, featuring a 180-degree design that equalized runner lengths and accepted 3 2-barrel carburetors. This manifold, combined with the big valve heads, pushed power output to 235 horsepower, nearly double the stock engine's output. The aluminum construction saved 40 pounds over the stock cast iron piece, improving weight distribution. The triple carburetors provided 540 CFM of airflow versus the stock 280 CFM, finally matching the breathing capacity of the modified heads. The racing dominance was immediate and overwhelming. In the 1953 Mexican road race, Edelbrock-equipped Oldsmobiles finished first and second in the stock car class, beating factory-backed teams from Ford, Chrysler, and even Oldsmobile's own works entries. At Bonneville, an Edelbrock Rocket set a new B-competition coupe record at 143.54 nm. In NASCAR, Edelbrock-headed cars won 40% of all races entered. What made this even more remarkable was the simplicity of the modification. While other speed shops were boring and stroking engines, installing wild camshafts, or bolting on superchargers, Edelbrock was simply allowing the engine to breathe as it should have from the factory. He wasn't adding displacement or compression or forced induction. He was just removing a bottleneck that shouldn't have existed in the first place. The impact on Oldsmobile was profound. By 1954, they quietly increased valve sizes on their racing homologation specials. The 1957 J2 Rocket featured 2.0-inch intake valves from the factory, larger than even Edelbrock's modifications. They never officially credited him, but the influence was obvious. Every subsequent Oldsmobile performance engine featured significantly larger valves than the original Rocket. But here's where the story takes an interesting turn. Oldsmobile wasn't angry about being outsmarted. They were learning. The success of Edelbrock modified engines in racing was selling more Oldsmobiles. Young buyers were choosing Rockets specifically because they knew about Edelbrock's modifications. The aftermarket was actually helping Oldsmobile's image as a performance brand. This symbiotic relationship between Detroit and the aftermarket was new. Previously, manufacturers had viewed modificators as warranty headaches and liability risks. But Edelbrock's professional approach and documented results showed that the aftermarket could actually enhance a brand's reputation. This laid the groundwork for the factory-supported racing programs and official performance parts that would define the muscle car era. The technical legacy of Edelbrock's discovery extended far beyond Oldsmobile. He had proven that cylinder head flow was the key to naturally aspirated power. This seems obvious now, but in 1952, most hot rodders were obsessed with displacement and compression. Edelbrock showed that a well-ported small engine could outperform a poorly breathing big engine. His work established scientific principles that still guide engine development today. The relationship between valve size, port volume, and flow velocity. The importance of maintaining proper port velocities across the entire RPM range. The critical nature of the valve job in determining overall engine performance. These concepts, pioneered in a Hollywood speed shop, became fundamental to all future engine development. The business impact was equally profound. Edelbrock's success with the Rocket V8 established his company as the premier cylinder head specialist in America. Orders poured in from across the country. He expanded from a 3-man shop to a 30-employee operation by 1955. He introduced new products monthly: valve covers, oil pans, camshafts, each designed with the same attention to detail as his original valve jobs. By 1960, Edelbrock Equipment Company was the largest speed equipment manufacturer in America. The catalog had grown from a single mimeographed sheet to a 64-page book featuring hundreds of products for dozens of engines. Annual sales exceeded $2 million, roughly $20 million in today's money, all from a discovery that Oldsmobile's engineers had overlooked. But let's talk about what Oldsmobile's engineers were actually thinking. Declassified documents from General Motors archives reveal the truth. Oldsmobile absolutely knew larger valves would increase power. They had tested 1.94-inch and even 2.0-inch intake valves during development. But they deliberately chose smaller valves for several strategic reasons. First was warranty concerns. Larger valves were heavier, which increased stress on valve springs and guides. At high RPM, this could lead to valve float and potential engine damage. With a 3-year, 36,000-mile warranty to honor, Oldsmobile couldn't risk widespread failures. The small valves provided a safety margin that ensured reliability across millions of engines. Second was manufacturing cost. Larger valves required more precise machining and higher quality valve seat materials to maintain durability. This would have added approximately $8 per engine in production costs, seemingly minor, but multiplied by 500,000 engines per year, that's $4 million in added expense. For a feature that 99% of customers wouldn't notice, it wasn't justified. Third was fuel economy. The small valves created higher port velocities at part throttle, improving fuel atomization and combustion efficiency. In EPA testing cycles that emphasized low-speed operation, the small valve engines actually performed better. With gasoline prices rising and customers increasingly concerned about operating costs, this mattered. So Oldsmobile wasn't incompetent. They were optimizing for different parameters than racers. But this conservative approach created the exact opportunity Edelbrock exploited. By focusing on reliability and economy over maximum performance, Detroit left enormous potential untapped in virtually every engine they built. This pattern repeated throughout the 1950s and 60s. Chevrolet's small block had restrictive heads that the aftermarket immediately improved. Ford's FE series suffered from poor port design that speed shops corrected. Chrysler's early Hemis had primitive intake manifolds that aftermarket suppliers replaced. In every case, the factory prioritized reliability and cost over performance, and the aftermarket filled the gap. Edelbrock's influence went beyond just parts. He revolutionized how performance modifications were developed and marketed. Instead of trial and error, he used flow benches and dynamometers to scientifically validate improvements. Instead of wild claims, he published detailed test results. Instead of backyard operations, he built a professional manufacturing facility with quality control standards that matched Detroit's. This professional approach legitimized the entire speed equipment industry. Insurance companies began recognizing properly modified cars. Banks would finance performance parts purchases. Even law enforcement became more accepting of modified vehicles that met safety standards. Edelbrock had transformed hot rodding from an underground activity to a legitimate industry. The company's growth trajectory was remarkable. By 1962, Edelbrock was shipping products to 14 countries. The catalog featured parts for everything from flathead Fords to the new Chevrolet 409. Employment had grown to 75 people. The company had moved 3 times to larger facilities, and it all traced back to those original rocket V8 valve jobs. Tragically, Vic Edelbrock Sr. died in 1962 at age 49, just as his company was reaching national prominence. But his son, Vic Jr., took over at age 26 and continued the expansion. Under his leadership, Edelbrock became the first aftermarket company to meet original equipment manufacturer standards. They supplied performance parts to Detroit's own special vehicle operations. The student had become the teacher. Today, Edelbrock Corporation generates over $400 million in annual revenue. They manufacture thousands of products for hundreds of applications. They own multiple brands and operate facilities worldwide. The company that started with an $80 valve job is now valued at over $1 billion, and it all began because one mechanic looked at an engine and saw what Detroit's engineers had chosen to ignore. The technical principles Edelbrock discovered remain valid today. Modern engines still follow the same relationships between valve size, port flow, and power output. The only difference is that today's engineers use computational fluid dynamics and 3D modeling to optimize what Edelbrock figured out with hand tools and intuition. The science has advanced, but the fundamentals haven't changed. Consider the current Chevrolet LT1 engine. It produces 455 horsepower from 376 cubic inches, 1.21 horsepower per cubic inch. That's naturally aspirated, emissions-legal power that would have seemed impossible in 1952, but look closely at the cylinder heads, massive 2.13-inch intake valves, carefully shaped ports with optimized velocity profiles, direct injection that eliminates the airflow restrictions of port fuel injection. Every advancement builds on principles that Edelbrock pioneered. The aftermarket performance industry that Edelbrock created is now worth over $40 billion annually in the United States alone. Companies like Holley, CompCams, and TrickFlow exist because Edelbrock proved there was a market for scientifically developed performance parts. The SEMA show, which attracts 150,000 attendees annually, grew from the foundation Edelbrock laid. An entire industry exists because one man outsmarted Detroit. But let's return to that original discovery for a moment. What Edelbrock really found wasn't just a technical oversight. It was a fundamental disconnect between how engineers and enthusiasts viewed engines. To Oldsmobile, the rocket was a reliable power plant for luxury sedans. To hot rodders, it was untapped potential waiting to be unleashed. Edelbrock bridged that gap, showing both sides what was possible when engineering excellence met enthusiast passion. This intersection of factory engineering and aftermarket innovation defines American automotive culture. It's why we have Hellcats and Z06 Corvettes and GT500 Mustangs today. Detroit learned that performance sells, and the aftermarket taught them how to deliver it. That collaborative relationship, sometimes tense but ultimately productive, started with Vic Edelbrock's valve jobs. Think about the broader implications. How many other industries have similar untapped potential? How many products are optimized for reliability and cost when they could deliver so much more? Edelbrock's story isn't just about engines. It's about looking past conventional limitations and finding hidden possibilities. It's about questioning why things are done a certain way and having the courage to try something different. The story also highlights the importance of practical knowledge versus theoretical expertise. Oldsmobile's engineers had degrees from prestigious universities and access to unlimited resources. Edelbrock had high school education and a small shop, but he had something they didn't: direct experience with what customers actually wanted and the freedom to experiment without corporate constraints. Sometimes the best innovations come from outside, the establishment. As we look at modern automotive development with its computer simulations and billion-dollar budgets, it's worth remembering that revolutionary improvements can still come from individual insight. Tesla wasn't started by Detroit insiders. The LS swap phenomenon wasn't orchestrated by General Motors. The diesel performance revolution came from independent tuners, not factory engineers. The spirit of Vic Edelbrock lives on in every garage innovator who sees potential where corporations see liability. What's particularly fascinating is how Edelbrock's modification philosophy has evolved but never fundamentally changed. The company still focuses on improving breathing, still prioritizes tested performance over empty claims, still serves the enthusiast who wants more from their engine. They've adapted to fuel injection, emissions regulations, and electronic controls. But the core mission remains identical to what Vic Sr. established in 1952. The Oldsmobile rocket V8 itself deserves recognition as one of history's most influential engines. It launched the horsepower race, inspired the small block Chevy, and established the architecture that American V8s would follow for decades. But it took Vic Edelbrock to reveal its true potential. Without his modifications, the rocket might have remained a footnote in automotive history instead of a racing legend. So, what can we learn from this Brooklyn mechanic who outsmarted Detroit? First, that expertise comes in many forms, and practical experience often trumps theoretical knowledge. Second, that conservative engineering creates opportunities for innovation. Third, that serving enthusiast markets can build billion-dollar businesses. And finally, that one person with insight and determination can change an entire industry. The next time you see an Edelbrock sticker at a car show or spot their distinctive carburetor on a classic muscle car, remember that it all started with a simple observation. Stock valves were too small. The fix cost $80. The impact was priceless. That's the power of seeing what others overlook and having the courage to do something about it. What's the most impressive engine modification you've ever seen? Drop a comment below and share your own stories of outsmarting the factory engineers. And if you enjoyed this deep dive into speed shop history, make sure to subscribe because we're just getting started exploring the untold stories of American automotive innovation.